Hi everyone, this is Savita Valsang and welcome to my channel Statistics Made Simple. And in this video, I'll be finding the solutions to the problems in section C of the new pattern question paper. Section C. Fourth main, answer any 8 of the following questions. There will be 12 questions and you have to answer 8, each of which carries 5 marks. 25th question, calculate total fertility rate from the following data. Age in years 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44 and 45 to 49. Corresponding female populations are 7,350, 7,400, 6,000, 4,980, 4,200, 3,900, 3,200. The corresponding number of live births are 190, 600, 540, 200, 110, 48 and 20. So let us first write TFR formula. That is, consider TFR is equal to 5 times summation quinquennial ASFR. This will carry 1 mark, where ASFR is equal to number of live births occurring to women in a specific age group divided by average population of women in a specific age group into 1000. So this formula will carry 1 mark. So now I have rewritten the table in a tabular format as columns. So we have age group in years, the female population and number of live births. So let us calculate ASFR for each of the age groups. As an example, for the age group 15 to 19. So I am going to calculate ASFR for the age group 15 to 19. So using the formula which I have already explained, it will be 190 divided by 7,350 into 1000. So according to the calculations, you'll get 25.8503. So let me write here 25.8503. So calculating in a similar way for all the age groups by using the formula number of live births divided by female population into 1000, we get the remaining ASFR values as 81.0811. The next one is 90. Then we have 40.1606. Then 26.1905. Then 12.3077. And we get for the last age group 6.25. Now, when I add up all these ASFR values, the total ASFR, that is summation ASFR, I get it as 281.8402. So, therefore, we get TFR is equal to 5 into, it is summation quinquennial ASFR. So, it is 281.8402, or the final answer is 1409.20. 26th question. What is an index number? Mention 4 limitations of index number. So an index number is a statistical device which is designed to measure the relative change in a variable or a group of variables with respect to time, geographical location, or other characteristics such as income, profession, etc. So this definition will carry 1 mark. Then the remaining 4 marks are for the 4 limitations. So there are actually 5 limitations of index numbers, but you need to write only 4 of them. So the first one is, while constructing index numbers, some representative items alone are made use of. So the index number so obtained may not indicate the changes in the concerned fields accurately. Second, as customs and habits change from time to time, the use of commodities also vary, and so it is not possible to assign proper weights to various items. Third, as all of you know, many formulae are used for the construction of index numbers. These formulae give different values for the index. Fourth, there is ample scope for bias in the construction of index numbers. By altering the price quotations or by improper selection of items, index numbers can be manipulated. Since index numbers are based on the sample data, they are only approximate indicators. And whenever we construct index numbers, the quality of the product is not taken into consideration. So the definition of an index number will carry 1 mark and 4 marks will be for the 4 limitations. 27 question. Construct consumer price index number by using family budget method. Group: food, clothing, fuel, entertainment, medicine and education, others. The price for the base year are 150, 70, 100, 50, 60, 80. Current year prices are 180, 90, 120, 80, 75, 110. And the weights for the corresponding groups are 65, 20, 20, 15, 10 and 15. So for the family budget method, the consumer price index number formula is summation WP divided by summation W, where capital P is equal to P1 by P0 into 100. So let me show how to calculate the price relative for food. So we have to make use of the formula P1 by P0 into 100. So before that, let me mark the price for the base year as P0. The current year price is marked as P1. The weights are marked as W. And if we calculate summation W, that is if we add up all the weights, then we get 145. So now let me go back to showing you how to calculate the price relative for each of the groups. For example, suppose we are calculating the price relative for food. It will be capital P is equal to 180 divided by 150 into 100, which is equal to 120. So similarly, we can calculate the price relatives for each of the different groups. So let me now form a column capital P. So the first price relative is 120. Similarly, the next one is 128.57. Then I have 120, 160, 125 and 137.5. Then what we need next is WP. So what we have to do is you have to multiply 65 by 120. So you get 7,800. Similarly, 20 into 128.57 will give 2,571.4. Next one is 2,400. Then again we have 2,400, 1,250, then 2,062.5. Then next you have to sum up all the WP values. So you'll get summation WP is equal to 18483.9. So let us now calculate CPI. So CPI is equal to 18,483.9 divided by summation W, which is 145. So we get CPI as 127.48. Twenty-eighth question. Calculate 5 yearly moving averages for the following time series. The years are 2007, 2008 up to 2014. Then the corresponding values are 30, 26, 36, 44, 52, 46, 53 and 62. So the given table, I have written it in a column format. So in the first column we have the years, in the second column we have the Y values. Now before we form the other two columns which are required, you first write down given. So in the question, they have asked us to find out 5 yearly moving averages. So it means that M is equal to 5. So M is called as the period of variation, and in this case it is 5, and 5 is an odd number. So usually when the period of variation is odd, keep in mind that you need to form only two columns. So for a 5-yearly moving average problem, you will need 5-yearly moving totals, and then you will need 5-yearly moving averages, which are nothing but the trend values. But if it is a 3-yearly moving average problem, again 3 is an odd number. In that case, you will need 3-yearly moving totals and 3-yearly moving averages, which are nothing but the trend values. So it's quite simple. The first step is to add the first 5 values corresponding to the 5 years and write it corresponding to their middle year. So add 30, 26, 36, 44 and 52. Now the middle year for these 5 values. So if I add these 5 values, the middle year will be 2009. So when I add these 5 values, I get the total as 188. So it is very important that you write the totals corresponding to the middle year. Next is you leave out the value 30 and add the next 5 values, that is 26, 36, 44, 52 and 46. So if you do that, the next total you get is 204. So proceed in a similar manner. Next you have to leave out the first 2 values and add the next 5 values, and you will get the total as 231. Similarly, the last one you will get 257. Now observe that whenever we calculate the 5-yearly moving averages, the first 2 and the last 2 totals will be missing. Or you'll see that in the last column, the first 2 and the last 2 trend values also will be missing. So now to calculate 5-yearly moving averages. Averages means you have to divide. Because you added 5 values, now you have to divide by the number 5. Okay, I'll just show the calculation here. It is 188 divided by 5. So you get 37.6. Similarly, 204 divided by 5, you will get 40.8. Next is 46.2, and then you will get 51.4. Now sometimes in a question they may ask us to write the conclusion or to give the comment. So for this particular problem, though they haven't asked, I would like to explain to you how to write the conclusion. Okay. So now keenly observe the values in the last column. You see that all the trend values, that is the 4 trend values, are increasing. So the conclusion will be the given time series indicates an upward trend. So the totals will carry 2 marks. The 5-yearly moving averages also will carry 2 marks, and the positions will carry 1 mark. And if there is a conclusion which has to be written for the problem, then that would carry 1 mark and the other marks will be adjusted accordingly. So 5-yearly moving averages and similarly 4-yearly moving averages is an important question. 29 question. Interpolate the value of y when x is 35 for the following data. So the x values are 10, 20, 30, 40 and the y values are 23, 30, 34 and 37. So we have to make use of Newton's forward difference formula to interpolate the value of y when x is given. So rewriting the table and forming the columns called as leading differences, I have delta to the power 1, delta square and delta cube. Now let me explain to you how to find out delta to the power 1. So 30 minus 23 will give us 7, and 7 you write it in between these values. So here I will write 7. Similarly, 34 minus 30 is 4. Write 4 in between 30 and 34. Then similarly find out 37 minus 34. This is equal to 3. Now let us find out delta square. So proceed in a similar manner. So 4 minus 7 will give us minus 3, which you write in between 7 and 4. Similarly, 3 minus 4 will give us minus 1. Next, we have delta cubed. Now, delta cube calculation will be minus 1 minus of minus 3. I'll just show the calculation at this side. So, it is minus 1 minus of minus 3, which is equal to minus 1 plus 3, which is equal to 2. So, do the calculations carefully because the signs are important. So, next you write 2. So you have to stop when you have only one leading difference in a particular column. The next important step is to mark the first values in each of these columns. So the first value under the x column, that is 10, is x naught. Similarly, the first value under the y column, that is 23, is y naught. Then under delta to the power 1 column, 7 is marked as delta naught to the power 1. Similarly, minus 3 is marked as delta naught square and 2 is marked as delta naught cubed. So now using Newton's forward interpolation formula, which is given by yx equal to y naught plus x delta naught to the power 1 plus x into x minus 1 by 2 factorial delta naught square plus x into x minus 1 into x minus 2 by 3 factorial delta naught cubed. The next step is to find out what is x. So to keep it quite simple, I will write where x is equal to. Now in the question they have asked us to find out y when x is equal to 35. So it is 35 minus x naught. So x naught is 10 divided by the difference between the x values, that is 20 minus 10. So this 35 is given to us in the problem. This 10 is the x naught value and this is the difference between two adjacent x values in the table. So simplifying, you get x is equal to 2.5. So it is very important to get this value right. So the construction of the table will carry 2 marks. Then the Newton's forward interpolation formula will carry 1 mark. And then you have to find out x correctly and do the calculations and get the value of y. That would carry the remaining 2 marks. So which implies y. Now in place of x you write 35, which is equal to, from the table, y naught is equal to 23 plus 2.5 into 7 plus 2.5 into 2.5 minus 1 into minus 3, and 2 factorial will be 2 plus 2.5 into 2.5 minus 1 into 2.5 minus 2 divided by 3 factorial will be 6 and delta naught cubed is 2. So on further simplification we get 23 plus 17.5 minus 2.5 into 1.5 into 3 divided by 2 plus 2.5 into 1.5 into 0.5 into 2, which is divided by 6, which is equal to 40.5 minus 5.625 plus 0.625. So therefore, we get y35 is equal to 35.5. 30th question. In a certain locality, it is known that 25% of the taxis have defective meters. Assuming that 100 investigators take a sample of 6 taxis each to see if their meters are defective, how many investigators will report that? First subdivision, exactly 3 taxis have defective meters. Subdivision B, at least 1 taxi have defective meters. Now, how to identify that this problem belongs to a particular distribution? So, when you see the word defective, it is based on the binomial distribution, and the binomial distribution has two parameters, that is n and p. So, n is usually a whole number and p is the probability of success, which is usually in percentage, decimals, or fractions. Now let us start the problem. First, write what is given. So in a certain locality, it is known that 25% of the taxis have defective meters. So this is small p, that is 25%. You convert it into decimals, that is 25 divided by 100 is equal to 0.25. Then you also need q, which is 1 minus p, which is 1 minus 0.25, which is 0.75. Assuming that 100 investigators, so this is capital N, which is equal to 100. So if you observe the question, they have not asked to find the probability, but they have said how many investigators. So whatever probability we find out, we have to multiply with capital N, that is N is equal to 100. So assuming that 100 investigators take a sample of 6 taxis, so that means small n is equal to 6. So we have the parameters n equal to 6 and p equal to 25%, that is 0.25. And we have also found out q and capital N. The next important step is to define capital X, which is number of defective meters. Then let us write down the probability mass function. P of x is equal to, the formula is NCX, so 6Cx, P to the power x, so 0.25 to the power x, Q to the power n minus x, so 0.75 to the power 6 minus x, and x takes the values 0, 1, 2, so on till n, so it is 0, 1, 2, 3, 4, 5 and 6. And then in the next line we write 0 otherwise. Now let me start with the first subdivision. So we have to find how many investigators will report that exactly 3 taxis have defective meters. So let me start with consider probability of capital X equal to 3, which is equal to P of 3. So now in the PMF, wherever you have x, replace it by 3. 6C3, 0.25 to the power 3, 0.75 to the power 6 minus 3. So if we simplify, we get 6C3 is 20, 0.25 cubed is 0.0156, taking 4 places after rounding off. Then 0.75 to the power 4 is 0.4219. So we get the probability of 3 defective meters is 0.1316. But the question is to find out how many investigators will report that exactly 3 taxis have defective meters. So therefore, the number of investigators who report that 3 taxis have defective meters is 100 into 0.1316, which is equal to 13.16, or if you approximate to a whole number, the answer is 13. Now let me start with the second subdivision. We have to find out how many investigators will report that at least one taxi have defective meters. So let me start with consider. Probability of x at least means greater than or equal to 1. So this is equal to, if we use a direct method, x greater than or equal to 1 means 1, 2, 3, 4, 5, 6. So you'll have to calculate 6 probabilities, so which will be very lengthy. Hence use the formula method, which is 1 minus probability of x, because on the left hand side you have greater than or equal to. When you use the formula method here, on the right hand side it will be only 1 minus probability of x less than 1. So x less than 1 means it is only probability of x equal to 0, which is equal to 1 minus p of 0. So in the PMF, wherever you have x, replace it by 0. So you will get 6c0, 0.25 to the power 0, 0.75 to the power 6 minus 0, which is equal to 1 minus 6c0 is 1. Any number to the power 0 is also 1. And 0.75 to the power 6, if you take 4 places after the decimal after rounding off, is 0.1779. So therefore, we get probability of x greater than or equal to 1 is 0.8221. But the question is not to find the probability, but we have to find out the number of investigators. So now write, therefore, the number of investigators who report at least one taxi have defective meters is, it is 100 into 0.8221, which is equal to 82.21, or if you approximate to a whole number, the final answer is 82. 31st question. There are 30 marbles in a bag, out of which 18 are red and the rest are blue colored. A child picks 5 marbles at random. Find the mean and variance of the number of red marbles. So this particular problem is based on the hypergeometric distribution. So the hypergeometric distribution has 3 parameters, n, a and b. So let us start by writing the information which is given. So given the total number of marbles in the bag is 30, that means A plus B is equal to 30. And then they have mentioned out of which 18 are red and the rest are blue colored. And the final question is based on the mean and variance of the number of red marbles. So be very careful here. So A will be the number of red marbles mentioned in the problem. That is A is equal to 18. So B will be equal to 30 minus A, which is 30 minus 18, which is equal to 12. Then they've also mentioned that a child picks 5 marbles at random, which means that the sample size n is equal to 5. And here x will be the number of red marbles a child picks in a random sample of size n equal to 5. Now let us start with the first subdivision. Write the formula for the mean of the hypergeometric distribution. So consider expectation of x is equal to NA divided by A plus B. which is equal to 5 into 18 divided by 30, which is equal to 90 divided by 30. Cancel out the 0 in the numerator and denominator. So you get expectation of x is equal to 3. Similarly, now let's find out the variance. Consider v of x is equal to, it is NAB into a plus b minus n divided by a plus b the whole square into a plus b minus 1. So which is equal to 5 into 18 into 12 into a plus b is 30 minus 5 divided by 30 whole square, and here you will have 30 minus 1. So which simplifies to 1080 into 25. 30 square will be 900 into 29. So which is equal to 27,000 divided by 26,100. Cancel out 2 zeros in the numerator and denominator. And after final simplification, you will get variance of x is 1.0345. So practice writing the formula of the mean and variance of the hypergeometric distribution. 32nd question. Among randomly selected 100 students of college A, 66 were passed. Among randomly selected 200 students of college B, 114 were passed. Test whether passing proportion is same in both the colleges. Use alpha equal to 1%. So we have two colleges, college A and college B, and the word proportion is used. So this question is based on test for equality of proportions. Now remember some important points, that whenever the problem is based on the test for equality of proportions, totally we will require 4 values in the problem. That is, first we will need n1 and n2, that is the sample sizes, and then we will also require x1 and x2. And keep in mind that x1 and x2 are always whole numbers, and they stand for number of units in the sample which possess a particular attribute. And here the attribute is the students who pass. Kindly ignore the grammatical error in the sentences. So what I mentioned here at this side, please keep it in mind. So now let us write down the 4 values given to us in this problem. So given, the word randomly selected means it is n1 is equal to 100, and 66 students passed in college A from that particular sample means x1 is equal to 66. Similarly, a random sample of size 200 was chosen from college B, which means that n2 is equal to 200, and of them 114 pass, that is x2 is equal to 114 and alpha is equal to 1%. Now H naught is of the form the two population proportions are equal, that is capital P1 is equal to capital P2, versus H1 P1 is not equal to P2. So this is a two-tailed alternative. So the words like above, below, increase, decrease, improved are not there in the question. So the alternative will be two-tailed. Now the next important step is to write the test statistic. So write the sentence under H naught. The test statistic is the formula Z equal to, this is small p1 minus p2 divided by root pq into 1 by n1 plus 1 by n2, which follows normal 0, 1. Now we have to calculate the sample proportions p1, p2, and also capital P, that is the population proportion. So P1 is calculated using the formula x1 divided by n1, that is 66 divided by 100, which is equal to 0.66. Similarly, P2 is x2 divided by n2, which is 114 divided by 200, that is 0.57. And capital P is estimated using the formula x1 plus x2 divided by n1 plus n2, which is 66 plus 114 divided by 100 plus 200, which is 180 divided by 300, which is equal to 0.6. Now we also need to calculate Q, which is 1 minus P, which is 1 minus 0.6, which is equal to 0.4. Now substituting all the values in the test statistic, we get, therefore Z is equal to 0.66 minus 0.57 divided by, it is root of 0.6 into 0.4 into 1 by n1, that is 1 divided by 100 plus 1 divided by n2, that is 200. So subtracting the numerator, we get 0.09 divided by root 0.24 into 0.01 plus 0.005. Even when we divide, let us take 4 places after the decimal if it exists. So this is equal to 0.09 divided by root 0.24 into 0.015, which simplifies further to 0.09 divided by root 0.0036, which is 0.09 divided by 0.06, which is 1.5. Previously, we obtained Z is equal to 1.5. Now, the condition which is required for a two-tailed test that will help us to accept or reject H0 is, I have to check if mod Z is greater than or equal to K alpha by 2. So, if this condition is satisfied, then I will reject the null hypothesis. And if this condition is not satisfied, then I will accept the null hypothesis. So it's important to write the condition at this side, or if you're used to drawing the normal curve and then taking a decision, you can do that as well. So now I will continue with finding out modulus of Z. So therefore, modulus of Z is equal to modulus of 1.5. Now, because 1.5 is a positive value, the modulus will remain as positive. But remember that the modulus of a negative number will turn out to be positive. So, mod Z is 1.5. Next, we should find out what is K alpha by 2. This can be obtained from the statistical tables, or if you can remember it, that is well and good. So, at 1% level of significance, K alpha by 2 is equal to 2.58. So now the last part is to write the conclusion. So all you have to do is you have to compare modulus of Z with K alpha by 2. So you can write, since mod Z is equal to 1.5 and we know that K alpha by 2 is equal to 2.58. Now check whether 1.5 is greater than 2.58. You see that it is not greater than. So at 1% level of significance, we accept H0 and conclude that capital P1 is equal to capital P2, or in other words, it means that both the population proportions are equal. 33rd question. The following are the marks of 6 students obtained before and after attending special classes. Student from 1 to 6. Marks obtained before special class are 80, 95, 92, 68, 96 and 60. Marks obtained after special class are 92, 90, 97, 74, 92 and 55. Test whether marks of the students have improved after attending special classes, and we have to use alpha equal to 5%. As you observe that the total number of students is 6 and they have given us the marks obtained by these students before and after attending special classes. So it is the paired T test. Now, the question asks us you to test whether the marks of the students have improved after attending special classes. So let me write this point at this side, which is important. So now, before special classes, the mean marks scored by the students is denoted by mu1, and after attending special classes, the mean marks of the students is denoted by mu2. So they have asked us to check whether mu2 is greater than mu1. But whenever we write the alternative hypothesis, we should write mu1 first and then mu2. So it means that mu1 is less than mu2. So be very careful here when you're writing the alternative hypothesis. This is an important point to keep in mind. So now let me start with the problem. I will write given n is equal to 6. And they have also mentioned that alpha is equal to 5%. Next, you write H0. The two population means are equal, that is mu1 is equal to mu2. And the alternative hypothesis will be versus H1, mu1 is less than mu2. Then under H0, the test statistic is, write the test statistic formula. T is equal to D bar divided by S subscript D divided by root of n minus 1, which follows Tn minus 1. Now also note down what are the formulae for D bar and for SD square. So D bar is summation D by n and SD square is summation D minus D bar the whole square divided by n. Rewriting the given table in a column format, I have the student number, then marks before special class and marks after special class. So marks before special class, I will mark it as X, and marks after special class, I will mark it as Y. Next, I'll find out D, which is equal to X minus Y. So form that column, that is D equal to X minus Y. So 80 minus 92 is minus 12. Next value is 5. Then you have minus 5, minus 6, 4 and 5. Then calculate summation D, which is equal to minus 9. So we know that D bar is equal to summation D divided by n, which is equal to minus 9 divided by 6, which is equal to minus 1.5. And we also know that SD square is equal to summation D minus D bar the whole square divided by n, which is equal to summation D minus, D bar is minus 1.5, so use a bracket, this whole square divided by 6, which will result in summation D, minus into minus is plus, 1.5 the whole square divided by 6. So in the table, form the last column as D plus 1.5 the whole square. So take the first value minus 12, add it to 1.5 and then square it. It will result in 110.25. Always remember that whenever you square a negative number, it will become positive. Similarly, when 5 is added to 1.5 and when you square it, you get 42.25. Continue in a similar manner. So 12.25, 20.25, 30.25, 42.25. So summation d plus 1.5 the whole square is 257.5. Substituting the total in SD square formula, we get SD square is equal to 257.5 divided by 6, which is equal to 42.9167. And again, remember here that we don't require SD square, but we need SD. So SD is equal to root 42.9167. So always take 4 places after the decimal after rounding off. So I get SD as 6.5511. Now let us substitute in T. So therefore, the test statistic T is equal to minus 1.5 divided by 6.5511 divided by root of 6 minus 1, which is equal to minus 1.5 divided by 6.5511 divided by root of 5, which is equal to minus 1.5 divided by 6.5511 divided by 2.2361. Be careful with all the calculations, which is equal to minus 1.5 divided by 2.9297. So therefore, we get T equal to minus 0.5119. Now remember that this test is a left-tailed test. So what is the condition which we have to use? That I will write it at the side. So the condition is you should check whether T is less than or equal to minus T alpha. So if this condition is satisfied at alpha level of significance for n minus 1 degrees of freedom, then we will reject H0, otherwise we will accept H0. So now let us find out the degrees of freedom, which is n minus 1, which is 6 minus 1 is equal to 5. So we have the T value. Next we need minus T alpha. This we can find out from the statistical table. So at 5% level of significance, for 5 degrees of freedom, minus T alpha is equal to minus 2.02. This we get from the statistical table. So the last step now is to write the conclusion. So since T is equal to minus 0.5119 and minus T alpha is equal to minus 2.02, you have to check whether minus 0.5119 is less than minus 2.02. Okay, so you see that it is not less than. So at 5% level of significance, for 5 degrees of freedom, we accept H0 and conclude that mu1 is equal to mu2. 35th question. Solve the following LPP graphically. Maximize z equal to 100x plus 200y. Subject to the constraints are x plus y greater than or equal to 10, 4x plus 5y less than or equal to 40, and a non-negativity restriction is that x and y are greater than or equal to 0. So let us start with the solution. there are various steps in drawing or finding the solution for an LPP graphically. So step 1 is to convert inequalities to equalities. So when you have greater than or equal to or less than or equal to in an equation, they are called as inequalities. So the first inequality will become x plus y equal to 10, and the second inequality will become 4x plus 5y is equal to 40. So this is the first step. Second step is you have to obtain the points of the two lines. So whenever we have to draw a straight line, we need a minimum of 2 points. So that's what we're going to do in the second step. So now consider the first equation, that is x plus y is equal to 10. Here you put x equal to 0. When I do that, I'll get y equal to 10. And similarly, when I put y equal to 0, I get x is equal to 10. So we write therefore 0 comma 10. So first you should write x and then you should write y, and 10 comma 0 are the points of the line which is x plus y equal to 10. Now similarly, consider the next equation. 4x plus 5y is equal to 40. Now put x equal to 0. So you'll get 5y is equal to 40, which implies y is equal to 40 divided by 5, that is equal to 8. In a similar way, put y equal to 0. So you get 4x is equal to 40, or which implies x is equal to 40 divided by 4, that is 10. So therefore 0, 8 and 10, 0 are the points of the line which is 4x plus 5y equal to 40. Now step 3, to draw the graph. We have to draw the graph now. So the first equation was x plus y equal to 10, and the 2 points which were obtained are 0, 10 and 10, 0. And for the second equation, 4x plus 5y equal to 40, the 2 points are 0, 8 and 10, 0. So now let us draw the graph. On the x-axis, I will take the scale as 2 centimeter is equal to 2 units. So start with the origin and then mark 2, 4, 6, 8 and 10. You can choose whatever scale you want. Then similarly on the y-axis, I have taken 2 centimeters is equal to 2 units. So again I have marked 2, 4, 6, 8 and 10. Please note that my graph is not accurate. Now let us draw the first line. So let us mark 0, 10. So x is 0 and y is 10. So this is a point x equal to 0 and y is 10. Then the other point is 10, 0. So on the x-axis, you have 10 and y will be 0. So mark this as 10, 0. Now join the points 0, 10 and 10, 0 by a straight line. And on this line, write x plus y equal to 10. That is the equation. Similarly, for the second equation, the first point is 0, 8. So x is 0 and y is 8. So this is the point 0, 8, and the other point is 10, 0, which is the same as this. So join the points 0, 8 and 10, 0 by a straight line, and on that line write 4x plus 5y equal to 40. Now let's continue the problem with the next step. The next step is step 4. To obtain the feasible region. So to obtain the feasible region, we have to consider the inequalities which were given. Only to draw the lines, we converted the inequalities to equalities, but to obtain the feasible region, let us go back to the inequalities which were given. So I will take the first inequality, that is consider x plus y greater than or equal to 10. In this inequality, put both x equal to 0 and y equal to 0. So if you do that, on the left hand side you will have 0 and on the right hand side you will have 10. Now check whether 0 is greater than 10. So 0 is not greater than 10. So you will write false. Similarly, take the next inequality. What is the next inequality? 4x plus 5y less than or equal to 40. Now here again you put x equal to 0 and y equal to 0. So when I put both x and y as 0, on the left hand side here I will get 0 and on the right hand side you have the number 40. Now check whether 0 is less than 40. So 0 is less than 40. So we write true. Now remember that whenever it is true, we have to shade towards the origin, and when it is false, we shade away from the origin. So let me write that here. When it is true, shade towards the origin. And when the condition is false, shade away from the origin. So all these points have to be kept in mind to take a decision. So now let me take the first equation. Okay, that is x plus y equal to 10. So when we consider the inequality, we got the result as false. So when it is false, you have to shade away from the origin. So this is the line. The origin is here. So away from the origin means you should shade on top of this line. And the other inequality, we got it as true. So for true, you have to shade towards the origin. So this is the line and the origin is here. Towards the origin means below this line. So now what you observe here is there is no common feasible region. That is, the two types of shading are not intersecting at any point. So it means that the LPP has no solution. So let me write the final conclusion. The given LPP has no solution. (36) question. Obtain an initial basic feasible solution to the following transportation problem by matrix minima method. Also obtain total transportation cost is the solution degenerate. So they have given us the origins as P, Q and R, and the availabilities at these origins are 20, 30 and 50, which will be denoted by AI, and the destinations are X, Y, and Z. The requirement at these destinations are 40, 10, and 50, and the requirements will be marked as B1, B2, and B3. Now note that the matrix minima method is also called as the least cost entry method. So let's start with the solution. So I have rewritten the table, and here in the table 10, 6, 7, 5, 4, 6, 6, 7, 9. These are all the costs involved in transporting quantities from different origins to different destinations. So first I'll mark 20 as A1, 30 as A2, 50 as A3. Then here 40 is marked as B1, this is B2 and B3. Now when you add the AIs and when you add the BJs, you get the total as 100. That is summation AI is equal to summation BJ. Such a type of transportation problem is called as a balanced transportation problem. Now, the first step is to find out the least cost. So the least cost in the given table is 4, and 4 is in the second row, second column, that is cell 2, 2. So the least cost is 4. That is, we write C22 is equal to 4. And we have to make the allocation in that particular cell. So X is equal to minimum of A, B, and because this is cell 2, the subscript for X will be 2. The first 2 you write for A, and the second subscript 2 you write for B. That's an easy way to remember, which is equal to minimum of 30, 10. So you get X22 is equal to 10. So the allocation is denoted by X. So when we say allocation, it is the quantity which is transported from the origin Q to destination Y. So I'll just change the color. So here I'll make a small square and write the allocation 10. Now, because we have made this allocation in cell 2, 2, you have to check whether this allocation 10 matches with the availability at Q or whether 10 matches with the requirement at Y. So we see that this 10 matches with the requirement 10 at Y. So I will write the sentence requirement at Y is satisfied. So you have to delete column Y. So I will delete column Y, and for this particular cell the availability will change now, and we write A is equal to A minus X. So A is A2, here also it will be A2, minus the allocation which you just now found out, that is X22, that is equal to 30 minus 10, which is equal to 20. Then cancel out 30 and write the allocation 20. All the calculations can be shown in one table itself with the corresponding steps, but because I don't have space in this particular slide, I will rewrite the table again in the next slide. Now I have just rewritten the table again with the previous calculations that are marked. Now I'll start with the second step. Now next, in the remaining cost, find out the least cost. So you see that the least cost is 5. So I will write least cost is 5, and observe that the least cost in the second row first column. So I will write that is C21 is equal to 5. Now write the allocation as X is equal to minimum of A, B, and because this 5 is present in cell 21, the subscript here will be 21. Write 2 for A and 1 for B. So it is minimum of 20, 40. So therefore you will get x21 is equal to 20. Now this allocation should be written in the particular cell. So here is the least cost 5 and the allocation, that is x21, will be written here as 20. Now check whether this allocation 20, it matches with the availability at Q, or whether 20 matches with the requirement at X. So we see that 20 matches with the availability at Q. So I will write availability at Q is satisfied. And so you have to delete Q. I'm just keeping it short. It's actually like delete row Q, but you can just write delete Q. This is only for your understanding. And now because you have deleted Q, you have to see corresponding to this allocation, what is the requirement. The requirement will change now. And B is equal to B minus X. So for this particular allocation, B is B1. So B1 is equal to B1 minus the allocation which you found out, X21. That is 40 minus 20 is equal to 20. Now score off this 40 and write 20, and don't forget to delete row Q. Now let us proceed further. Find out the least cost in the remaining table. Okay, so now step 3. Now the least cost which is present is 6. So write least cost is 6, and 6 is present in cell 3-1. So that is C31 is equal to 6, and make the allocation X is equal to minimum of A, B. So 6 is present here. So X will be 3-1. Write for A the subscript as 3, and for B it will be 1. So this is equal to minimum of A3. A3 is 50 and B1 is 20. So which is equal to 20. So therefore X31 is equal to 20. Now write the allocation in that particular cell. So I will write 20 here. Now check whether this 20 matches with the availability 50 or whether it is matching with the requirement 20. So we see that requirement at X is satisfied. So you have to delete X, and for this particular cell you have to change the availability, and A is equal to A minus X. So A will be A3 is equal to A3 minus X31, which is equal to 50 minus 20, that is equal to 30. So score of 50 and write 30. And let me not forget that I have to score out the column X. So the next least cost is 7 among 7 and 9. So the fourth step, least cost is 7. That is C13 is equal to 7. And the allocation will be X13 is minimum of A1, B3, which is minimum of 20, 50. So therefore we get X13 is equal to 20. So now let us write the allocation in the cell. So here let's write 20. Now observe that 20 matches with the availability at P. So availability at P is satisfied. Delete P. And now you have to change the requirement. B3 is equal to B3 minus X13. So therefore B3 is equal to 50 minus 20, that is equal to 30. So score of 50 and write 30, and don't forget to delete row P. Now the only cost which is remaining is 9, and it is present in cell 3, 3. So the fifth step, the least cost is 9. That is C33 is equal to 9, and X33 will be minimum of A3, B3, which is minimum of 30, 30. So therefore X33 is equal to 30. Then write the allocation in the cell. So you see that this 30 matches with the availability at R, and it also matches with the requirement at Z. So you have to delete row R and column Z. And the problem ends because there is no other cost which is remaining. Okay, so we will write here availability at R and requirement at Z are satisfied. So delete R and Z. Now we have to write down what is the initial basic feasible solution. So therefore, the initial basic feasible solution is, you have to list down all the allocations which you found out. So X13 is equal to 20, X21 is 20, X22 is 10, X31 is equal to 20, and X33 is equal to 30. Now in the next slide, I will find out what is the total transportation cost and check whether the solution is degenerate or not. I have written all the allocations in their respective cells. Now let us find out the total transportation cost. So the total transportation cost is Z equal to, so every allocation should be multiplied by the corresponding cost and they should be added up to get the total transportation cost. So Z is equal to 7 into 20 plus 5 into 20 plus 4 into 10 plus 6 into 20 plus 9 into 30. So simplifying, this is equal to 140 plus 100 plus 40 plus 120 plus 270. So we get the total transportation cost as Z equal to rupees 670. Now the next part of the question was to check whether the solution is non-degenerate or not. So I will first write down the number of positive allocations. So if you see the above table, we see that we have 1, 2, 3, 4, 5 allocations. So number of positive allocations is equal to 5, and we'll find out m plus n minus 1. So m stands for the number of rows, n stands for the number of columns which we have. So we have 3 origins and 3 destinations. So m is 3 and n is also 3, minus 1 is equal to 5. Next, we will write the conclusion. Since the number of positive allocations within brackets 5 is equal to m plus n minus 1 within brackets, that is also 5, the solution is non-degenerate. This video has been a lengthy one, but I'm sure that it will be very helpful to many students to solve the questions from section C of the new pattern question paper. Thank you all for watching, and look out for my next video where I will solve the problems from section D of the new pattern question paper. Thank you.